This video is going to go over the chapter review from the textbook. So it starts with 8.1, which was the similar polygons. Numbers 1 and 2 say to find the scale factor, list all the pairs of congruent angles, and write the ratio of the corresponding side lengths in a statement of proportionality. So the first thing we have to do is figure out what sides match up with what sides. If I look at that first one, it's turned on its side so that DC would actually match GH. So 12 would go to 9, or 8 would go to 6. And then for both of these, they would reduce to be 4 to 3. So that's your scale factor. The corresponding angles are congruent angles. Angle A would equal angle E. Angle B would equal angle F. Angle C would equal angle G. And angle D would equal angle H. Normally, I would just match up the letters here, and that's how I would get it. This time, they're all 90 degrees, so they actually are all equal, but that's definitely an exception. And then it says, write the ratio of the corresponding side lengths in a statement of proportionality. So again, order is important. AB would go over EF. BC would go over FG. CD would go over GH, and AD would go over EH. That would be your statement of proportionality. This at the top is referred to as your statement of similarity. So if you see that, that's what that means. Number 2 is these triangles. Again, you want to match up the order. So the smallest side would go with the smallest side, which means YZ would go with PQ, or 15 would go with 6. The middle length side, the XZ would go with the middle length side, QR, or 20 to 8. And then the last one, the XY would go with the PR, or 25 to 10, and all of these reduce to 5 halves. So that's your scale factor. Here's your statement of proportionality, and then the angles. Angle X and R match. They have one arc and one arc. X equals R. Y and P, the second in both. Also, the one without the mark. And Z and Q would equal each other. They both have that right angle. All right, looking at number 3, it says 2 similar triangles have a scale factor of 3 to 5. The altitude of the larger is 24 inches. What's the altitude of the smaller? So the ratio of the altitudes is the same as the side lengths, which would be the same as the scale factor. If my scale factor is 3 to 5, that's small to large. And I have the large altitude, that's going to go in the bottom. So 24 goes in the bottom, and X is what we're trying to find. Cross multiply here. 3 times 24 would equal 5 times X. 72 would equal 5X. Divide by 5. And X equals 72 over 5, or divide that out. 4.5. So 14.5. Number 4 says 2 similar triangles have a pair of corresponding side lengths that are 12 and 8. The larger triangle has a perimeter of 48 and an area of 180. Find the perimeter of the area and the perimeter. All right, so, or find the measure, sorry, of the perimeter and the area. So the scale factor, which was 12 to 8, or 3 over 2, because 4 goes into both of those, would be the same as the ratio of perimeters. So if the larger one is 48, then the perimeter, which we'll put as X, would go in the bottom. We could cross multiply, but you also, if I divide 48 by 3, it's 16. So I can also just multiply 2 times 16 to get what's missing here. X would equal 32. But you'd get the same thing by doing 3x equals 48 times 2, so 96. And then x would equal, divide by 3, 32. The second part of this is the area. So if my scale factor is 3/2, the ratio of the areas is that squared, or 9/4. The large area is going to go in the top. That's 180. The bottom is your x. So I can multiply 9 by 20 to get 180. If I do the same with 4, I get 80. Or I can cross multiply. 9x would equal 180 times 4, 720, and then divide by 9. And x is 80. So the perimeter is 32 meters, and the area would be 80 meters squared. Okay, then it goes to 8.2, which again will get looped into 8.3, which is those angle, and side, angle, side, and side, side similarities. So just make sure that you realize that by the time we get to the test, they're all going to be grouped together. In this review, it's just angle at this point. So 5, 6 say to show that the triangles are similar, write the similarity statement. In 5, Q and T are congruent, and then these two angles would be congruent because of the vertical angles theorem. So these are similar because of the angle similarity. Similarity statement is which triangle. So triangle QRS would be similar to, now we went Q first, which matches T, so T has to go. R was the one that wasn't marked, which would be U, and S is this double arcs, or the vertical angles. So that order of that is important. 6, you've got the right angle here and here, so that's already one pair. Because these are right triangles, if I take the 60 away from 90, the missing angle is 30, which lines up with the E. So again, this is angle similarity. And if I call it triangle ABC, I went the 60 degrees, which would be the D, to the 30 degrees, which would be the E, to the 90 degrees, which would be the F. And the order of the letters should go like that. They could be rotated, but wherever the A is should be D, wherever the B is should be E, wherever the C is should be F. 7, cell phone tower casts a shadow that's 72 feet long, while a nearby tree that is 27 feet tall casts a shadow that's 6. So we've got a tower that we don't know how tall it is. It casts a 72-foot shadow. And then a tree that we know is 27 feet tall casts a shadow that's 6 feet long. Because these have that right angle and the angle of elevation would always be the same, these are going to be similar triangles had I actually closed them in, but you don't need to. You could just set up your proportion. So I can say x over 72 equals 27 over 6, or I could say x over 27 equals 72 over 6, or you can flip it, any order like that. So 3 goes into 6 twice and into 27 9 times. If I cross multiply here, I get 2x equals 72 times 9, which is 648. And then I would divide both sides by 2, and x equals 324. You can also simplify this side. This is actually 12 times, and then you could just multiply 27 times 12. And you get the same number. All right, A3 then brought in side, and side angle, side similarities. So when you're looking at the directions, just says show that the triangles are similar. For A, you'd have to show that they all line up. And for B, you'd have to show that the two pairs of sides are proportional and the angle between them, which would be your vertical angle, would be congruent. So now with 8 and 9, it says use side, similarity, or side angle side to show the triangles are similar. For 8, you've got that top angle that's shared by both. So that's your angle between. And then the sides 4 over this whole side, so 4 over 12, would have to equal 3.5 over this whole side, which is 10.5. So this is 1/3. If I move this over, that's 35 over 105, which is also 1/3. For number 9, you've got this angle here, so you have to use the sides. You can't use the 15 or the 10 if you want to use side angle side. If you don't want to use side angle side, you can also use side, side, side by showing 9 over this whole side, which is 13.5, would equal 14 over this whole side, which is 21, would equal 10 over 15. So 2/3, 2/3, move this and move this. 45 goes into that, 2/3. So again, you can either use the angle in between and the two sides as side angle side, or you can use side, side, side. All right, number 10 says find the value of x that makes triangle ABC similar to DEF. So in order for these triangles to be similar, and we know nothing about their angles, all three sides would have to be proportional. So AB, which is the first two letters, would match DE. 6 over 24, or 1/4, would be the scale factor of the small to the large. So I can either say 1/4 would equal 2x, which is BC. That's going to match the EF. So 2x over 32. Or I can say 1/4 equals 9 over 6x plus 12. Since obviously that one's a little bit more complicated, this is definitely the easier way to go. You can even simplify 2 into 32 16 times. So I can get 1/4 equals x over 16. And then I can cross multiply, or this is just by multiplying by 4. So if I do the same thing there, x is 4. If you work it the other way, I'd get 6x plus 12 times 1, so it stays the same, would equal 36. 6x would equal 24, and x would equal 4. So both ways you should get the same answer. All right, then came 8-4, and 8-4 was it's technically 4 theorems, but we didn't use the converse as much unless we're showing that the lines are parallel. What we did use is the triangle proportionality, which says that that side, if it is parallel to this third side, then it cuts the side lengths proportionally. We had the angle bisector one, where an angle bisector cuts the side opposite also proportionally with the sides of the triangle. And then the third one, which was the 3 parallel lines, and the 3 parallel lines and 2 transversals would cut these side lengths, A, B, C, D, proportionally. So if you look at 1, it's actually saying determine whether these are parallel, and that would be what you would use the converse for. So 10 over 16 would equal 20 over 28, or I could go 20 over 10 should equal 28 over 16. This would be 2 to 1, this would not. So this is no. Repeat that process for 12. 13.5 over 22.5 should equal 12 over 20. If I move this decimal, I get 135 over 225. 4 goes into both of these, it'd be 3/5. So then I would just see if I could divide the 225 by 5. And I know I can, but I want to see what I get. 20, that's 45. And see if 135 is also divisible by 45. And it is. And it would reduce, so if I divided them both by 45, it would reduce to 3/5. Because those are the same, this one is a yes. All right, question 3 says to find the length of YB. So if these are parallel, which they are marked as parallel, then 15 over 24. I don't know why I did that. 15 over 24. 15 over 24 should equal 7 over YB, which we can make X. And then I would cross multiply, or actually I can reduce these. 3 goes into both, that'd be 5/8. So 5/8 equals 7 over X. Now cross multiply, 5X equals 56. Divide both sides by 5. And X equals 11 and 1/5. You could have also done 7 over 15 equals X over 24. Number 14 is your 3 parallel lines. And again, these are cut proportionally. So I can do 6 over 4 would equal x over 7. Reduce again. This would be 3/2. So 3 times 7 is 21 equals 2x. Divide both sides by 2. And x is 10 and 1/2, or 10.5. You could have also done x over 6 and 7 over 4. Remember, there's more than one way to do those. 15 is your angle bisector theorem. So that angle bisector divides your opposite side into segments that are proportional with the sides of the triangles. So I can say 10 over 4 equals 18 over x. Or I can say 10 over 18, so left over left, would equal 4 over x. They both reduced, so I would say it doesn't really matter which one you pick. Let's say you pick the 10 and 18. This would be 5 and 9. So 5 over 9 would equal 4 over x. 5x would equal 36, and x would equal 36 over 5, which is 7 1/5, or 7.2. All right, that's the whole packet. Hopefully that helps you prepare for the test and answers any questions. There will be one more review to prepare yourself for the test. Have a good day.